Sick of needing a jump start, a hip swing, or a cheeky assist from the table to get that tail swinging? Well, stop thrashing around and jump for joy because we have the product for you. Introducing MYOwnTail, the tail that moves when you do. Let's hear from the creator of MYOwnTail. MYOwnTail is, at its heart, a work of biomimetics. Most animal muscles use series actuation and elasticity rather than the rotational motion one sees out of most electric motors. I had considered series elastic actuators for this application, however it seemed unnecessarily complicated and expensive for something like this. What seemed more appropriate was turning rotational motion into contraction using a wire along a flexible core, and a pulley system which would pull this wire and have it cause a curving motion at the top of the tail along the length of the tail. There are quite a few works out there that make use of this principle, and I found one I thought would work very well. In terms of material, there was really no question that the first version, at least, should be made out of plastic, as it has made the iteration process simply a matter of changing something I thought needed alteration and 3D printing a new part. I thought my first tail used mostly parts that were in the original design I found online, printed on a hand-tuned printer bot. The electronics were implemented on an Arduino Uno, and the muscle sensors were MyOware's basic product. This worked very well, though several things jumped out as needing improvement. First was that the tail itself was not wearable, lacking any attachment points for a belt. It also had a lot of electronics that were outside of the tail itself and would tend to shift and fall off surfaces during demos. Finally, the wire slipped out of the pulley system quite a bit, decreasing the amount that the tail itself would bend. The wheel itself was also not optimized for attachment points for the wire. This is the second version. The original one was rounded here, and I had to slice it off a bit. Here, I printed it out flat, so I could just drill a hole and thread it and put a screw here, glue in, and have the wires where that needed to be. And so in the second version, as I mentioned, I added a belt loop opening here and made the wheels deeper to try to hold the wire better, decreased the main wheel size, as you can see in the picture and in the demo you'll be seeing on the day and in some of the videos, that the main wheel was about this big. It fit the whole area, which is why this had to be this size. I shrank it to possibly even shrink the whole thing. I also did add indentations for for the breadboard here, and ideally what will happen also in later versions is that this wire will actually be not protrude quite as much. Possibly just turn the whole servo around. I mean, it doesn't have to be this orientation. It's just easier for me when I'm building it. And here's the indentation for the Arduino Micro. Also, in the second iteration, the majority of the these tail rings here are now acrylic rather than 3D printed plastic. Makes it easier to produce them. It's quite an easy thing to assemble. Just thread the holes. You see a lot of screws on this. You thread all of those holes, and you just screw it together. And there's silicone adhesive for each end of the tubing here to stick it to the ends of the support and wiring system. And there's some amount of adhesive hot glue here to hold the spring on, and hot glue for the wire on the main wheel. The rest of it is all done with screws. The servo itself is just the basic thing you find on Adafruit. I'm, as I said, probably for iteration 3 going to try to find something with continuous or 360-degree rotation. And as you'll see in the demo video that should be playing in a moment, or even while I'm talking about this now, you'll see that the muscle sensors work quite well for making it go back and forth. And, I mean, even just a basic swing back and forth in time looks quite natural. And once it's in a better enclosure, a furred enclosure like you have on the first suits, it should look quite good. As you can see, I'm having a little difficulty here because it does escape the wheels very easy, this wire. And part of the program was also that and again you'll see this as the video goes on, that I set it so that if there was that one of the problems with the EMG sensors is they have a tendency to echo a lot. That is, that you put some bang into them with your muscle activation, and it just sort of stays activated. I think that's more of a problem with the muscle than the sensor than the muscle, because obviously the muscle can't stay activated for that long after it's finished. So I may look into other sensors, and in any case, what I do is I have it go into this neutral position if both muscles seem to be activated, and for the most part, it works quite well. Run to the nearest fur con and buy My Own Tail.